a user requested some assistance in understanding the processing Ombre. So I'm going to redo it. The Ombre site has changed a little. My site has changed a little. So this is sort of a, as of September 2025 walkthrough and make life easy for people working with Ombre. So first thing all you do is you click sign in and it spins a little bit. And there we have the login, and you can see my last result, which is 91, which is a good, healthy result. Now, what we want to next, and we have advertising. After dismissing the advertising, click bacteria level, and we have download my data. So click here, and it will proceed. Let's get a bit better example. Oh, it will basically ask to download. There we go. There's the download and the sample, and I'm going to actually put a little name in front of it. So you download that, you figure out where. In this case, I'm dropping it into my downloaded directory. You can save where you want to, do slave, and then it ends up downloading. And that is it for the site. You can now go over to microbiome prescription and go and click up upload your sample. And you go down here until you see Ombre or 5 Inside. 5 Inside was the old name. Click that. You go and choose your file. And I had done that down into downloads. And give me a second to find it. Okay, there we are. Give me 1 second. And there we find our little file there. Notice I put the word demo in front of it to make it clear, better improve clarity as to which file I'm working with. Click that. Type in my name, and I'll do ken.lassison@gmail. And upload and consent to terms. The sample date, update that as appropriate, which means just clicking here. And suppose this was probably back August 1st. Put that in there. Upload and consent. And now we see it spinning up here. And voila, we have uploaded. And now we have there. Now, we could do knobs, just tell me what to take and avoid, which is fine. And what if you do that, let's just do that for the sake of completeness. Open up a new window. It will go and compute everything and comes back with suggestions. First of all, bacteria which are out of range, 195. Then it goes, and this things you should take, things you should avoid. The weight there is the confidence of it actually improving things or not improving things, and that's based on the number of studies that report this GOS, for example, improving different bacteria, and which bacteria are you trying to change, etc. So that is the idiot way of doing it. My general preference is always go over to bacteria symptoms, and oops, right there, and it will go and list out things, for example, night sweats, something which I have, and actually I don't have daytime sleepiness, even though I'm 73. Most other things actually don't apply to me, apart from night sweats, which occasionally are happening. And now I just click that and get suggestions, and now it goes and do there. And notice we have less bacteria. What we have done is we have used information from other people's studies who have night sweats, and we say where does our pattern bacteria match theirs with high statistical significance. And we find that there's 13 ones which are there, and then down below it gives specific things for the bacteria selected. Keyword for the bacteria selected, and the bacteria selected are the bacteria which have been associated with night sweats with the symptoms you entered. And you go down and you see things to take and things to avoid. Ginkgo greens particularly comes out, and it just goes down the list. Again, of course, you can go back here and you can change what type of suggestions you want. For example, if you want to avoid antibiotics, you click that, and whatever else you want to do. And there now, we also have, although our sample here, when we go down here, we may have probiotics listed here or may not, but we also have um, consensus report. So if you type consensus report, it will go to the complete list, which in this case is 516 different items had positive or negative impact. And we could go up here, and if you're interested in just probiotics, we just click here probiotics, and we see which probiotics are the best ones to take. And we see the combination there: Ramosis, Savannas, Casei, etc. So those are the best one. And clicking here to put in a reverse order, we find the ones we should probably avoid taking. And you will find, for example, Bifidobacterium is here, Ramosis GG is to avoid, but Ramosis was to take. And this is based on the studies. Now we have one more way of getting probiotics, and I will go back and do it, and that is scroll down, and it is search engine based on uh, oops. Oh, I know where it is. If we go back here, consensus report, and if we go back here, then we use R2. We use the same bacteria. In this case, we're looking at 13 bacteria only, and we see what happens and comes up with the ones which are the uh, with the best ones. Some of these are in development, like the Goseni, which has been used in studies, hence it's included in here, but it may not be available where you are. Sake is there, Pantherium, which I think is also on the other one, and it goes to this there, and again, clicking here takes you from the best to the worst ones. Again, it varies. Things may disagree between them, and there's no magic way of which one is best. The two ways are done in two different ways. This way is done on the using a 1,000 sample with shotgun, which is more detail of microbiome and finding relationships and saying, okay, this probiotic increases some bacteria. Let's go out and do a positive one instead. And let's go down to something. Okay, Lactobacillus brevis. If you click here, and it will go over and show, and it will show you what bacteria it increases and decreases. And down the bottom, we have the full list. In this case, we have calculated 157 bacteria, which appears to be positively or negatively impacted by this particular lactobacillus. So that is done using a clinical quality subset of bacteria. The other way of doing it, which is using the method, is based on clinical studies. So one is inferring from a large set of samples, and the other one is from what a study. The actual thing is the large set of clinical samples is far more accurate than most clinical studies because we're dealing with 1,000 samples. Most clinical studies deal with 30 or 50. So the accuracy you get from 1,000 is far better than the accuracy you get with 30 or 50 individuals in a clinical study. And often those studies are people with medical conditions which will bias. The 1,000 study which we're using are 1,000 people deemed healthy, so we are seeing what the response is in a healthy one. So that is basically it. It's pretty straightforward. Suggestion is to mark out everything you have here. If you have a two samples, you can go up and compare it to other things, a whole bunch of things, which I will not go get into right now. Experiment or one main thing I want to show is how to get your basic suggestions. Novice is you don't put in any symptoms. Beginning symptoms, you go in, you see what the prediction symptoms and mark the ones which are matched. And what does that do? That means we have less noise in the bacteria we want to address. Many of the bacteria may be high or low without causing any symptoms. If you focus on the ones which are symptom related, we get a far better result, as in the suggestions are more likely to actually work for you in a shorter period of time. Okay, and with that, I'll say bye bye and get this up on the web.